Hello guys, so in this video we will be talking about solid principle. Okay, so let's start. First let's understand why do we need it. Apart from that generic answer that obviously they are one of the most important interview questions, and even if you're not preparing for interview as a developer, you should be knowing all this because they definitely improve the way you are writing the code. Okay, but another important aspect of knowing solid principles is that when you are writing a code in a big company or a production code, and assuming you have written a code without following solid principles, so the code would look like a very big function. Now when you try to modify that code, there are high chances that you will produce a side effect. You don't know what to test, what not to test, and sometimes it's even difficult to understand that. Sometimes it's very difficult to extend that code and there are many other issues associated with it. So to fix all those issues, we must follow solid principles. Okay, now we'll start with what are solid principles are. So solid principles are basically the combination of 5 principles. First is single responsibility, O is open close principle, L is Liskov substitution principle, I is interface segregation principle, and D is dependency inversion. And please remember, dependency inversion is not dependency injection that we read in Spring Boot. They both are different concepts. Okay, so let's start with single responsibility principle. As the name suggests, this principle states that every entity, be it a class or function, should handle the single responsibility. That is, every class should have a single reason to change. Now the obvious questions that comes to mind: how do we define single? What should be the size of single, right, when we are talking of the practical problems, right? So the optimal size depends on the specific component, the type of application you are creating. As a developer, sometimes you need to trust your instinct that this should be the optimal single size. If you feel by choosing that single you are having too many classes and there is a problem called class size expansion, so you can merge some of those in a single class or single file. Right, so that as a developer you have to take call as and when you get experience, you get to know okay, you can define this much as a single responsibilities. Okay, so now let's understand single responsibility with the help of an example. So let's say we want to design a zoo game, and most important thing in a zoo game would be an animal, right? So now let's try to define an animal class. So how would the animal class look like? So we have an animal class with few attributes, that is few properties, which are the weight, color, species, number of legs, whether it has wings or not, and following behavior or functions like fly, eat, swim, breathe underwater, and breathe only. Okay, now when we try to define a swim method, which would look like if species equals to shark, then we say out swim, fish swim. If the species is pigeon or species is cheetah, what should our swim function do? Because neither pigeon nor cheetah or many more other animals do not swim, right? Now this is the problem with this code. How do we fix it? We follow single responsibility principle. So actually the issue here is that animal is handling too many responsibilities. It is handling the fly responsibility, eat responsibility, swim responsibility, and many more, right? So how do we fix it? We try to segregate the responsibilities into different classes. And how are we doing it here is, we have created the animal class. Now we have made it abstract class, and we have given it only the eat responsibilities, assuming every animal must eat, right? So now just give me a minute. So now animal class has only eat responsibility, and all is removed from it. Now we want to define the bird class and the fish. Now how do we have defined bird? Now we have created a class bird which is extending the animal class. Bird has the functionality of fly, run, breathe on land, and it's extending the eat from animal. Same goes for fish. Fish has swim, breathe underwater, and it's extending eat from the animal class. Okay, so that's how I've fixed the previous problem. Now swim is not defined for cheetah or bird or pigeon, hence the issue is fixed now. Okay, now moving to another principle, which is the open close principle. This principle states that your code should be closed for modification yet open for extension. What is mean by that is, whenever you're trying to add new functionality, or whenever there's a piece of code and you are adding new functionality, you should follow that you are not modifying any existing code, yet you should be able to extend that code, you should be able to add new functionality. Okay, now we'll see this with the help of an example. Okay, so let's design the bird class. In the previous example, we have seen that we have created a separate bird class which is extending animal, and there's a fly function in it. Now we are defining that fly function. So let's say there is a species variable, and based on a species we are defining that fly behavior. So if the species equals sparrow, then we are defining some fly behavior. If the species is pigeon, then we are defining some fly, some fly behavior, right? But now the issue is, in this code, let's say this code is a library code, right? And if you want to add more species, how do we do it? So this is the library code and this is the main function. So I cannot add a new species without modifying the fly function, right? But our open close principle suggests that you should be able to extend that code. That is, in this case, we should be able to add a new bird without modifying the existing code. But we can't do this, hence it's breaking the open close principle, right? Now how do we fix this? So again, the same solution. Instead of defining the complete fly behavior inside the bird class, we have make it an abstract class. So now the bird class has become abstract, which is again extending animal, and it's just saying that I will have fly behavior and each bird can define their own fly behavior. So now a sparrow is defining its behavior, pigeon is defining its fly behavior. So for sparrow and pigeon, nothing changes. They have this similar fly behavior as they have earlier, right? Now when we try to extend the code, that is, now when we try to add a new bird, let's say we are trying to add a peacock, we don't have to modify any of this code, and still we are able to extend this code, that is, add the new bird which is peacock here, and we can define its fly behavior here now. So this is what open close principle is. We are able to extend that code without modifying the previous code. Now why it's important? It's important because this is a very basic example, but let's say you must have some test case written for fly, or you are sure that fly function is working fine. When you modify this function, you don't know what could break, okay, in the production. But with this approach that we have done is, we have not touched that code which was tested earlier. We have only created a new class, so we don't need to retest all the previous code, and we are sure there will be no side effects, and we only have to test the functionality for this class, right? So this is the open close principle. Now moving to third principle, which is the Liskov substitution principle. Now this principle states that any functionality in the parent class must work also for the child class. In other words, if some piece of code works with the parent class P, it should also work unmodified for the all child class C, which is again extending P. The important keyword here is unmodified. So the functionality which is working for the class P, parent class, should also work unmodified for all the child class of the P. That is, in simple words, any extension to the existing code should not break the existing feature. And somehow, if you see, this is also related to the previous principle we have seen. We are in the previous principle, we are extending the code, right? This principle states extending the code should not break the existing features, and we'll see how can the features break and how can we modify the code that they are not breaking, right? Now, so now again talking about bird class, we have seen the bird class with the fly function, right? So we have reached that there is abstract class with the abstract function fly, and each bird is defining the fly behavior, right? Now let's say we are extending the code again, and now we have created a class kiwi which is extending bird. Now kiwi can't fly, right? How do we define the fly function? There are multiple things. The throws exception, we don't implement fly, which is not possible in Java, because if you are extending the abstract class, you have to you have to define all these, override all the abstract functions, right? Returning null or anything else. So let's see with the most common approach that is used actually, which is the throwing exception, right? So let's say we have created exception, can't fly exception, and Kiwi throws the exception, can't fly. This code will work. What happens is let's say this is the code, this is the main function, and bird B is we are getting bird from some other code which is not changing. Previously we are getting only the instance of pigeon, peacock, sparrow, but now once we have the kiwi function, sometimes also kiwi is getting it. So bird can be instance of pigeon, sparrow, peacock earlier. Now kiwi is also coming. Once we start throwing exception in here, what would happen is this p.fly was working fine earlier, but with this extension, once we have added kiwi, it starts breaking sometimes because kiwi is throwing the exception. Now this violates expectations. What expectations it breaking? We have seen here, if some piece of code works with a parent class P, that is, if piece of code was working for all the bird class P, it should also work unmodified for all the child class C. That means if our code was working for all the bird classes, it should also work for kiwi class, right? And this expectation is violating here. How can we fix it? So this is just summarizing the issue that we have. I'll just summarize it again, that before extension our code was working fine. After extension, the code fails at random point. It's no longer working for all the scenarios, right? How do we fix it? Now we have removed the fly behavior from the bird class. Now our bird class does not have fly behavior. Let's say it does have only speak behavior now, and we have moved the fly behavior to the interface I can fly, right? So now sparrow, pigeon, or other birds which can fly, they are now defined like this: class sparrow extending birds implements fly. So they still have the fly behavior like earlier, but since kiwi can't fly, they are just extending bird class and they are not implementing the I can fly. Hence there is no need to implement fly function, and hence the issue has been fixed, right? This is the Liskov substitution principle. Now the interface segregation principle. It states that it's better to have many small interfaces rather than a very large interface. Okay, too many is better than too few. So let's understand with the example. So now let's try to add more functionality to I can fly interface. Earlier we have fly function. Now we have added flap wings, kick off, ground to take off, and some random bird which is the sparrow. And we have defined all the functionalities for a sparrow, and it all makes sense here. Okay. Now fly is a generic behavior. So like I can also add that fly to a, let's say, vehicle which is airplane. Okay. So I've created a class which is extending vehicle and implements I can fly because we needed a fly behavior here. Now, but flap wings and kick off, ground to take off, these functionality does not make sense for an airplane because flap wings only a bird with the wings can do. Kick off, ground to take off, again only a bird will do, right? So now these are the extra functionalities here, and we cannot throw exception here like we've discussed earlier, which will violate the Liskov substitution here. So what needs to be done here? How can we fix it? Instead of having a one interface having too many functionalities, we can create small interfaces. So what we can do is we can move flap wings and kick off ground to a separate interface, which is only added in the case of birds, and fly, since it's a generic interface, which can be used by bird as well as vehicles, because with Java there is also flexibility that you can extend only one class, but you can implement or extend many interfaces, so there will not be a problem of extending multiple interfaces. Okay, so this is the interface segregation principle. Moving to last, the dependency inversion principle, which states that higher level modules should not depend on lower level modules. Instead, they should depend on abstraction. So we'll not discuss definition now. Let's first see some example and then we'll come back here again. Okay, so now we have seen the animal. Now we want to define the animal cage. How would the cage look like? So this is the class tiger which is extending animal. Again, let's say there is a class hen which is extending animal. It's not written here, but let's see, we'll see this also. For a cage, there would be we need two things. One, the type of bars it has. So let's say we have defined an interface I bars, and we have three type of bars: wooden bars, iron bars, small gap bars, and there could be multiple more. And there are what type of feeding bowl that cage would be having. One would be meat feeding bowl, one could be fruit feeding bowl, and there could be many more type of bowls there. Okay, so if you want to define some cages, how can you do? The one way is we have created a class cage1, and we have added meat feeding bowl with wooden bars, or let's say iron bars, and we have added tigers here. Okay, another it, let's say we want to create it for hen, so I've added fruit feeding bowl, wooden bars, and hen. So these are the two cages, and they seemed okay, and there is no as such issue in this code. But again, with respect to solid principle, there is one issue. What's that? So before understanding the issue, let's just see the diagram first. So then in blue we have the abstractions. This is the I feeding bowl, I bars, and animals. These are the implementations. Meat feeding bowl. So meat feeding bowl is inheriting I feeding bowl. This just arrow is showing. Iron bars is implementing I bars, and tigers is implementing or extending animals. And cage1 is composition of meat feeding bowl, iron bars, and tigers. Composition, that is, it has cage1. And the cage1 has meat feeding balls, iron bars, and list of tigers. So here the issue is, for every type of cage we need to create a new class. We can't simply create the cage object, because each cage is it's hard coded. The things are hard coded, that this cage will have only meat feeding balls and iron balls. And there could be 10 different types of cages, so we need to create 10 different classes. And this is what dependency inversion was stating, that higher level module should not depend on lower modules. Instead, it should depend on the abstraction. So the cage class should not depend on this layer, it should depend on this layer. Now, what would the code look like once we fix it? So now, instead of multiple cage1, cage2, we have only one class cage. Now it depends on the interfaces: I feeding bowl, I bars, and list of animals, not tiger or hen. And when we want cage, we are simply creating a cage objects, cage1 and cage2. Cage1 has meat feeding bowl, iron bars, and list of tigers. And cage2 is fruit feeding bowl, wooden bars, and list of peacock or hen, whatever. So cage1, cage2 are now simple instance which were earlier defined as extra classes. So now we don't have to create class again and again. We can simply create the objects. Okay. So these are all about solid principles. I've seen multiple people ask me this thing, that how are solid principles used, and what is the relation with design patterns? So we are not talk much about design patterns here. We'll create separate videos on different design patterns later on, but I would like to say solid principle is the way of you writing the code, and design patterns helps you to write the code which follows solid principle. So let's say strategy or factory patterns helps you design the open, closed, or single responsibility. So summarizing it again, design patterns will help you write the code which follows solid principles. So this is how design patterns and solid principles are linked. Thank you guys, and if you have any doubt or any comment, please let me know. I'll definitely respond. Thank you.